Oh, yay. Okay, so 9.2, linear regression. Y'all let me know when you can't see me. Okay. Okay, so this is stats class. There's a lot of computation, but we do need to define things first. So obviously, like, we have sentences that we need to write down. I could just say this, but I think writing it is going to be better. After verifying, because this will link together what we did in 9.1 with this section. So after verifying a linear correlation between two variables is significant. So we calculate the correlation coefficient, right? We're able to actually tell that it is significant. After we've done that, now determine the equation of the line that best models the data. We use this, y'all, to be able to predict values, okay? And so that's kind of what the next little sentence says here. We have what is called the regression line. Okay, and it is an equation used to predict the value of y for a given x, which is kind of like that little example we just did. Okay, so we've determined that it's significant, and now what we can do is determine the equation that models that data. And what we use is this regression line, which is an equation used to predict the value of y for a given x. Okay, so I need to define something else. They are known as residuals. Okay, so I'm going to do a little graph. I might have to change pages to do it. I'm pretty sure I will. And the actual graph is going to kind of show what's happening here. These residuals, what it says is for each data point, okay, so you're going to do a lowercase d sub I. So the subscript, right? And so you're going to use this for each individual data point. That I just technically means that you're going to do the subscript for however many d's you have. So it'd be like d sub 1, d sub 2, d sub 3, d sub 4. So this d sub 1 represents the difference between the observed y value and the predicted y value. For a given x value. I feel like I might be able to get a little bitty thing here. If it ends up being too small, y'all can tell me and I can switch pages and just kind of make it a little bit larger. You could make a note here. I'm not going to do it because I know it'll take up too much room for me. The differences of the residuals, y'all, okay, and it doesn't make sense yet because I haven't really showed you what I'm talking about, but the residuals can be positive, negative, or zero. Okay, so residuals can be positive, negative, or zero. Now I'm going to do like an XY axis. Right, horizontal is my X, and then the vertical is my Y. And then let's say that we have all these data points, and what we're doing is we're just going to have like this linear model, right? We're trying to actually have this equation that can predict. Okay, so say I did the line first because it's just easier for me, but usually you would have a couple of little data points and then you would draw the line, just trying to explain it. But I did that and I had to rewrite this whole page over again. It's better for me to do this. Pretend like that line's not there yet, right? And I'm taking people's ages and their weights, or the ages and their heights, or their income, or their whatever, right? And I've got these data points, okay? Now let's say that I have this data point right here. Then I've got one right here. I have one here, and here, here, and here. Right, now after I've kind of got this scatter plot of data, then it's like, okay, now I would kind of draw that line, right? Right in the middle of the data points, this right here is going to be like my linear model. Now as far as the linear regression is concerned, or the actual data points that I was talking about, let me do this legend. So there's going to be two different things that I have here. The data points that you see that I have filled in is what would be called our observed Y values. Those are my data points. I can observe those, right? Those are actual data points from what I've collected. Now, to figure out the residuals or the differences between the observed and the predicted, we have to have our predicted values as well. The predicted values are going to line on the linear model that we're believing is going to predict and have the best fit of all this data. And so it would actually be, if this is my observed Y value, and you go straight up to your linear model, do an open circle there. That would be the predicted Y value. So here I have an open circle and I have predicted Y value. And then do it to the next data point, and the next one, and the next one, and the next one, and the next one. That little baby one's gonna give me a hard time. Now, these different residuals, or the actual like D sub i's for all the different data points, I'm gonna turn my paper because I want to show that it's this distance right here that can be calculated. I kind of did like a brace. This I would call D sub 1. That is the first distance between a observed value and a predicted value. D sub 1, right? So I have the actual observed value that came from my data points, and then I'm predicting it and putting it on this line. I'm trying to figure out what line is the best fit for all these data points, right? And so I did like the curly brace, and I call that D sub 1. That's my first data point. Now do the same thing for the next one, call it D sub 2, is kind of how it is. And so this would be D sub 2. And then up here, I would kind of just turn it. And that would be my D sub 3, because that's my third data point. It's hard to do little baby braces. And D sub 5. And this would be like my sixth data point, and that would be my D sub 6. Okay, I need to write this. I'm gonna kind of try to show this a little bit better. I want to write something right here. Okay. So I could kind of write it right here. For a given X value, this is how we would calculate those residuals. Okay, for a given X value, the way we would solve this as far as our d, like, which is the distance, you take the observed y value, which would be like, say, this d sub 2, whatever value is here, and then you would subtract the predicted y value. Okay, so you just make sure you have that note on there, y'all, that the residuals can be positive, negative, or 0. Okay? And I keep saying this line that best fits this data, right? We've got all these different data points. What is the linear model that would fit all of them appropriately? It's actually called the line of best fit, which is that regression line, which is what we're fixing to go through next.
What is between the y value? Is that a space?
Yeah, like y dash value here.
No, between that and the
So the way that we would figure out the little d, the simple d, would be the observed value and then subtract the predicted value there. Those parentheses should help a lot. Oh. Okay. So now let's actually kind of break down all of these different things that we'll use to solve this, okay? Okay, so regression line, open your parentheses and then write line of best fit, okay, because that's what it is. Your regression line is going to also be called your line of best fit. Because you can't just pick a line that goes along with one of those data points. We have all these different data points in all these different areas. What is the best line that fits all of them? And here are all the different chunks that we need to know and like the way that we'll solve this, okay? So we had that d sub I, right, which was all of our different data points. So we're going to need to take the sum of all of our different data points squared. So I have sigma d sub I and then the little exponential 2. Okay, so right here next to this, I'm going to write the line for which the sum of the squares of the residuals is a medium. I'm going to put this, I couldn't really sum it up more into like layman's terms, but in case, you know, sometimes the homework will ask certain things or like definitions. I wanted to make sure that I put exactly what they said in case you saw a problem that asked you to like explain this. So, the line for which the sum of the squares of the residuals is a minimum. I'm trying to find the line of best fit. Hopefully it makes sense that I need the math to work out to where there's not a big difference between the line and all the different data points. It needs to be the best as possible. And all this is doing right now in English words is showing you the order of operations. Right? Okay. Then we have, okay, so it's like notation. We did the equation of a line or slope intercept form, which is y equals mx plus b. If you're in algebra, you use y equals mx plus b. The fun thing in stats is we get to do a whole bunch of other mathy things. And we're going to kind of change that equation of a line slightly. This is called y hat. Okay? It's literally a lowercase y with a hat drawn on it. Okay? And it is going to be equal to mx plus b. So, this is a regression line. for an independent x, I totally ran out of room, and dependent y. Okay, so we know that m equals slope, right? So this is where m equals slope, and b equals our y-intercept. What do you mean? What's a kite? I don't understand. Oh, you can go do whatever you want. You're an adult, babe. Oh, yeah, no. You're fine. Okay, so whenever we use y hat, this actually gives us the predicted y value for the given x value. Okay, and as I said, the whole regression line of best fit, all we're trying to predict values. Okay, so y equals mx plus b is the equation of a line. When you see y hat, the m is still your slope, the b is still your y-intercept. But actually solving this, we're figuring out our prediction based off of the data that we've been given. Okay, and we figured out a line that fits all those data points as best as possible so that we can predict future values of different x values. Okay, so this right here is predicted y value for a given x value. Just trying to make somewhat sense of like what we're doing here. He really confused me asking me if he can go do something. It's on you, not me. Okay. So, do you see how the y has a different notation, correct? M is still a slope, b is still your y-intercept. But because we're talking about y hat and we're talking about a regression line, obviously, things are going to be slightly different than we're used to. Slope is what, in college algebra, it's like rise over run, right? You get the difference of your y values over the difference of your x values. That's not our slope in this class, okay? Our y-intercept is also not going to be how you would figure it out in that class or in college algebra either. Here, go ahead and write our slope, m. Okay, so how do we figure out our slope, in this class for y hat with the line of regression? Okay, so we have our m is equal to, do your big fraction bar. It's one of those, which can easily be broken down into little chunks, but it does look a lot crazier than it should. So numerator, you're going to start with taking your data points, and you're going to multiply it to the sum of x and y's product, which is the sum of the product of x and y. Product meaning it was a multiplication problem, right? You're going to subtract from that. And then if you open your parenthesis, we have the sum of our x values, close your parenthesis, open again, and do the sum of your y values. And remember, all of this is going to be shown by hand, obviously, and then I'm also going to show you how to use the TI-84 calculator. Can't make you buy it, but I can recommend it, okay, because it's just so much easier. Okay, this is what you would revert back to hand if you just can't get your calculator right, or you have a calculator similar to an 84 and I don't know how to explain it and you also don't know how to use it, then obviously this is the best thing to do. In your denominator, you're going to start with your data points multiplied to the sum of your x values squared. And remember, you do each, it's like a little table. You figure out your x's, figure out your x squared, multiply this. Sorry. That's an x. N, yeah. So N is your data point. I think that bottom N looks a little like an H. I'll tell you right now, we don't have an H at all today. Not in, we shouldn't have an H at all today, like in either lessons, but it's a real proud, trying to stand tall N is what that is. Okay, and then we're going to subtract from that. Open your parentheses and sum your x's, close, and then square that quantity. So definitely a little bit different than the college algebra slope, right? Okay. Remember, if you find each little individual and then you sum, you're just placing those numbers into your little formula right here. And then you could use your calculator. Okay, so what else do we have? One more thing that we need to know is our y-intercept, which is our b, won't be calculated the way that you may be used to seeing it, okay? So our Y-intercept I kind of went ahead and just put quotes on the M and the B. Okay, so our slope, which is our M, and then our Y-intercept, which is our B. How do we solve for our B? Okay, so our B is equal to, so they kind of break it down into two different chunks, like a simpler chunk, and then they like really explain that one just in case, okay? So what you do is you take the mean of your Y values, and you subtract from that your slope, which we would have previously found, multiplied to the mean of your X values. So remember, we would have this little table of all your X's, all your Y's, multiply the X's and the Y's, square this, square that, right? At the very bottom, you have all your sums, all your sigmas, right? Now, the mean would be found by adding up all your Y's, right? And then dividing by the number of data points. We did that. That was like first section or something that we did when we were figuring out like the standard deviation and stuff. So it's going to take this little explanation of how to find your Y-intercept, and then it's going to kind of explain the exact same thing again, but actually showing you like this is how you would do the mean. Add them up, divide by the number of data points, right? And then how would we do this? So we would subtract. We have our slope. We already know how to do slope. There's no reason in the world right now we need to replace this M with all of this. Okay, we just define that. Just use your M. And then the mean of your X values would be adding up your X values and dividing by the number of. Okay, that shouldn't be necessary to show y'all because we have done this section and y'all have taken the test and you should know how to find your mean, but doing this, it's just explaining it to you in a different way. Okay, don't think that it's like this one huge long run on and you're supposed to do all this work and then you get confused. This is the simpler version. Actually, this would be the more explanation, simpler version, what you're finding. When is your break? 10:45 a.m. Okay, moving on. Now what we're going to actually do is find the equation of the regression line for the time spent studying and grade point average. So it's like an example, okay? Okay, and you'll see all of this kind of in play and how it's the same type of thing. Find what are your X's, what are your Y's. Square your X's, square your Y's, multiply them, take the sums, plug them in, okay? Same stuff we've been doing, and then I'm going to show you the calculator as well.
So like the slope on the bottom, yeah, the bottom part of it, what's the difference between those two X's?
Okay, so this one is parentheses, order of operations. It's the parentheses. So what, like if, say we're doing this by hand, right? And we're like plugging stuff in. Again, you have this option. If you have the other one, you kind of do have to do it by hand. But with an 84, I'll have something that, I mean, obviously I'm testing, did you even pay attention? Do you know what you're supposed to do with these tables, right? But I'm not going to have you do a whole entire table by yourself because like that just takes too long. So here it is the number of data points times the sum of all of the squares of your X's. So you square them all and then add that up, right? Then we're going to subtract from that what? Take the sum of your X's and then square that sum. Yeah, so that those parentheses actually completely change everything, okay? Okay. Okay, so I know I said it, but now we got to write it. Find the equation of the regression line. And blah, blah, blah. I'm going to write example first because that's usually how I like to do it, so I'll solve that. Find the equation. Y'all, this is the section right here. Okay, this is the math that we need to do. Find the equation of the regression line. Thank you so much. Of the regression line for time spent studying each week and grade point average. y'all, this section in a nutshell, right? I'm going to get all of the times that y'all's been studying. I'm going to look at your grade point average. I'm going to plot that data. I'm going to figure out and calculate what line best models that data, so that whenever someone tells me how much time they've been studying, I could put it into the little equation that I found, and I could estimate and kind of predict this is what you should have for a grade point average based off of the data of everyone else's. Like that's pretty much what we're doing here. Okay, so say we have time is our X and GPA is our Y. And then I have 1, 2, 3, 4, 5, 6. I have 6 different data points. Okay. And then what I did, just so that I could do this whole problem and like understand whatever the homework might ask, was I went ahead and I used my calculator. I entered in the X's and the Y's. I figured out the correlation coefficient, made sure it was significant, because it's like once it's significant, then you could do the linear regression. Okay, just so you know, I'm going to actually do that as well. So it's going to be a twofer. Okay, so I've got time spent. The first student that I asked, they spent 2 hours a week studying, and their grade point average was a 2.1. And then the time spent for the second student that I asked was 8 hours a week, and their grade point average was a 3.2. For the third student, they spent 12 hours a week, and their grade point average was a 3.9, 6 and 3.0, 4 and 2.5, 5 and 2.7. 9.1 was all about correlation, right? Like, is there a correlation between how much you study and what your grade point average is? Remember, if you got really, really close to a +1, it was a strong correlation that the more you study, the higher your grade point average would be. Does that make sense? Like, that's kind of what we did the last time. And just because, even though I'm looking at the homework, I kind of come up with my own numbers. I wanted to make sure that I did have a strong correlation, because that would mean that based on a critical value, it was significant. Once you determine it's significant, then you can do this. Okay, so I had to do that just to make sure that my example wasn't a bad example. So what I did was I entered this data into my calculator using my TI-84. I touch stat, enter, it opens up my list. I'm going to clear these lists just because I already used this data. You go up, you type clear, highlighting L1, and you hit enter. If you do delete, it's going to delete that actual list, and then we've got to reset your calculator. So don't do delete, right? Go over, and if you highlight 2, hit clear, because I had data already in it. L1, that's my list 1, that's my X values. So 2, 8, 12, 6, 4, and 5. Scoot over, it highlights like the beginning of the second list. I have 2.1, 3.2, 3.9, 3.0, 2.5, and 2.7. Make sure that they're even, because I'm really, really bad at like not paying attention or my nails hitting something. I second mode to quit, to just kind of go back home. It's just second and mode. Your calculator could be different, but I just want to get out of my list. The second, the top blue button, and then right next to it where it says mode, that gets you out of anywhere you are and sends you back home, because it actually quits whatever it is that you're doing. Okay? And then what I want to do, since I'm trying to see if my example is even a decent example, I want to calculate to see what the correlation coefficient is. I want it really close to 1, so it's strong, so it would be significant. And then I kind of came up with a critical value to make sure I can make it significant. But you hit stat again. If you go over to calculate, my fourth option is lin reg, AX plus B, which is linear regression, AX plus B. I hit enter. If you notice, it says X list, L1. That says all my X's are stored in L1. Y list is L2. That's exactly how I did it, so that's good. If, say, you had multiple problems you're working at the same time, you could change those lists, okay? And then just keep on hitting enter, enter, enter. That's storing the regression equation. Keep hitting enter. Okay, so do you notice how it says y equals, and this is a, I guess it would be like a cheat, because we're fixing to do it by hand. But I want you to notice how it says y equals ax plus b, right? This is giving me what I need. This is giving me my linear regression, okay?
So,
But I'm going to do it by hand first and show you in the table.
So mine gave me the option of either picking y equals ax plus b or y equals
A plus bx, do the ax plus b. Kind of sucks because it is mx plus b when you write it on paper, but what they're using is the variables a and b. A is your m, a is your slope, b is your b. But you want that x variable next to your slope, which would be that, like in the leading, yeah, in the first one. Okay, so again, y'all remember, I'm doing this to test, like, hey, did I even come up with an example that can be calculated correctly? And I noticed that whenever I look at this, I have a strong positive linear correlation. An example on the homework, y'all, when you do this step, that is the cheat that skips doing the table all by hand, you already have what they want for your equation, okay? I am heading just a little bit, so it's kind of going back just a tad to 9.1. Here my R is approximately 0.994. I have an N of 6, which is my data points, right? And then again, I can move forward finding the best line of fit. It sounds funny to say that. When I know it's significant. So this example had to have, started with, some critical value. So I kind of selected that as well, looking at the Appendix B, Table 11. So if I look at the critical value, remember I kind of made all this up, of 0.05, I would see, I don't have it written down in front of me. I don't know why I didn't bring my book. I have the book in front of me, right? And I'm looking at the critical value because I'm kind of creating this example. And I know that my 0.994 is greater than what I'm looking at. And that's what I want to determine if rho is significant. If what I have for an R is less than, it's like you failed to reject it. There's a whole bunch of words. Basically, it just means it's not significant, okay? So here, just pretend like we have our book, we opened it, we looked on this table. Yes, my R is greater than, therefore rho is significant, which means now I can move forward with doing the regression line. I had to do this before we continued with this example. It's rho. It's, I kind of start at the bottom. If you did this, it's fine as long as you know that when you do a P, it's rho, but it's RHO. This is the population correlation coefficient. So you do the correlation coefficient for a sample, and then when you look at that little table and you go down, if what you solved for your R is greater than the value they have you look at, then you can say, basically we can apply our outcome to the sample to the whole population. It needs to be significant in order to be able to really apply it. So yeah, all of those were just my poor attempts at doing a rho symbol. 1, 2, 3, 4, 5, 6. N being your data points. And I surveyed 6 students, and there was just a total of 6 that I spoke to. So my data set is based off of 6 different things. Okay, so hopefully that did kind of make sense, y'all. Since I created my own numbers, I needed to make sure that it was significant before I did the line of best fit. Ugh. Touching that screen is kind of annoying. Okay, so I'm going to cover this up just a tad. So hopefully it doesn't. I want to show as much as I can. Okay. I think I might be able to pull off getting what I have on my paper here. So we're just going to kind of run with it, okay? Say I didn't show you that if you did stat, calculate, option 4, it showed you your equation. Say I didn't tell you that, okay? What you would do by hand, and again, I won't give you this whole entire thing on a test, but you need to know what it's comprised of and how you would, say, maybe create one of those lines, right? Okay, so this is what you would do, right? I know for a fact that I need to solve, so if it's y hat equals mx plus b. I need to solve for my m, I need to solve for my b, and those are those formulas that we just did on the previous page. Well, when looking at these formulas, hopefully it makes sense to you. I need my x's, I need my y's, I got those, right? I need to sum them individually. I need to square my x values. I need to square the sum of my x's, and I need to multiply them together and sum them. Like we've kind of broken them up before, so hopefully that kind of makes sense. I'm going to start by listing my x values. After that, I will list my y values. And then I would take the product of x and y. I noticed looking at the formula, I need to sum. I'm sorry, I need to sum the square of my x's. So that means I need a column which is squaring all my x's. Okay, because if I square all of them, I can then take the sum of the squares. I'm looking right now to make sure I got everything. What did I do here? And then I just square it. Okay. Okay, so let's go ahead and do that. I kind of just randomly switch colors. There's no real rhyme or reason, so just, I don't know. Let's see if we can see this color. My x's are 2, 8, 12, 6, 4, 5. My y values are my GPAs. Okay, and there's no reason to really like put this into a certain order. Okay, since y'all have everything written in front of you and I want to make sure that y'all can see this, I am just going to kind of show what I'm working with. So it's a little bit higher up for the ones in the back. Okay, so my GPAs are 2.1, 3.2, 3.9, 3.0, 2.5, and 2.7. Down here at the bottom, I waited until I saw how much room I took up writing down these data points before I did the sums. But I know looking at the formula, I'm going to need to sum my x's. And I'm going to kind of come down here, y'all, so I'm kind of smushing things together. I know that I'm going to need to sum my y's. If you wanted to do a line, that was kind of the line of best fit for these columns. And then we're going to multiply our x's and our y's together, and I see in the formula I'm going to need to take sigma x times y, the sum of x times y. And then I'm also going to be I'm going to be squaring all of my x's, and I look in the formula, I see that I also have to sum all of these values. After I square each individual x, I'm going to be adding them all up down here at the bottom. Okay, that's going to be the little setup that I will need to actually figure out what this equation is that is the line of best fit for all of these different data points. Okay, ooh, do I have to actually plot? I said sketch, and then I did a sad face because it's an ugly sketch. Okay, so if you do x times y, quite literally is I do second mode to go home. So if I do 2 times 2.1, I do 8 times 3.2, 12 times 3.9, or I'm multiplying x times y because that's what this column says to do. Okay, if I do 2 times 2.1, I get 4.2. And I'm just going to finish this column out. If I do 8 times 3.2, I get 25.6. 12 times 3.9, I get 46.8. 6 times 3.0, I get 18. 4 and 2.5, I get 10. 5 and 2.7, I get 13.5. I haven't even done my sums on the bottom yet. I'm kind of, doing all the columns and then I'll add them all up. Really doesn't matter. If you wanted to add these up now, you could. What I want to do is now take the square of all of my x's. So my x's here, that is the 2. So in this calculator, I can do 2. And above the log button, there is an x squared button that literally just squares them. Okay. So it puts a 2 up into the exponential field. If you needed to change it, you could. Obviously, it's telling me to square it, so I'm not going to change it. If you hit enter, I get 4. And then 8, hit that button, enter, 64. 12, hit the x squared button, hit enter, 144, so on and so forth. Okay, so I get 4, 64, 144, 36, 16, and 25. That is the square of each individual x value. Okay, now down here is where I'm going to go and sum them together. And you go down the column. So if I add 2, 8, 12, 6, 4, and 5, I get 37. If you add together every single one of those grade point averages, you get 17.4. And if you go through and you do 4.2 plus 25.6 plus 46.8 and you add all of those up, you're going to get 118.1. So 118.1. Okay, and that's adding up each individual data point. I'm sorry, not what I said, that each individual product of the x times the y. And then for the last column where we've squared all of our x values, if you add all of these up, you get 289. Those ugly formulas, I think they're beautiful, but they have the ability to be very ugly because they look super complicated. We've just figured out every single individual piece that we need to plug into it and then solve it. Okay, obviously use your parentheses, those are important. Okay, that's what tells your calculator to do the order of operations. It's not bad to maybe write it and then solve some of it, like, you know what I mean, like individually, and then put the last chunk in there, because putting stuff into your calculator, you could get an error if you mess up one single little thing, and then you're going to get frustrated. Okay, so I know that the whole reason why I'm doing this is to figure out y hat, right? It has an m and it has a b. We need to figure out what our m is. I'm going to kind of write a little small here. M equals, and I'm actually going to put what m equals right here. Okay, and then I'm going to do m equals again. I'm going to plug stuff in. I kind of hate that I tried to delete all that row right there, because now it's in my way. Okay, so you take the n times the sum of the product of x and y minus the sum of x times the sum of y. And then over here on the bottom, we have our data points times the sum of x squared minus open. And y'all, all of these formulas, I gave them to y'all already. That little packet that said key formulas, y'all can use that on the test. And remember, you can do a 3.5 note card. You cannot have a solved problem on there. And I have an hour and a half to do nothing but be lazy and bored and watch y'all. So I walk around and I look. You can have notes and you can have little processes and stuff that you can tell yourself. You just can't have like a whole problem solved out that you could just recreate. Okay. M equals. Let's plug this stuff in. N. What is N? I write 6. Now it says the sum of x and y. The sum of x and y is 116.6. Don't put 118.1. Don't put 6118.1. They're being multiplied to each other, so use your parentheses. And then subtract from that. If I see parentheses, I'm obviously going to use parentheses. Here, they don't show you parentheses because we just have different symbols touching each other. It implies multiplication. But when you plug stuff in, use your parentheses. Here, they had them, so for sure I'm going to include them. The sum of x is what? Close, open, sum of y. Close. If you're going to enter all this into your calculator, make sure you close right there, because if not, the order of operations, it's going to not be able to differentiate between your numerator and your denominator. It's going to give you an error, or it's going to give you a number that's wrong. For your denominator, we start with our n, which is our 6. I'm going to multiply it to the sum of the square of my x's. So I'm going to multiply it. You could use a dot if you want. I love parentheses. I'm going to open my parentheses. The sum of the squares of my x's is 289. Close. Subtract, open. Okay. Now, this is the sum of my x's, which is 37, close, and then you squared that quantity, okay? Don't think here that I use the 289, okay? Those parentheses in the formula are very important. Okay, and then my next step, I just have the answer. So let me show you how I would go about it. You could do each individual step and just keep bringing it down, right? Which there's nothing wrong with that. I'm assuming what I did was I created a little fraction on my calculator, and then I just went in and I put it exactly the way I see it. So what I would do, I always clear, just to kind of just make it not so cluttered. If you type or touch, the math button, and you go to the left, do you see where it says N over D? That means numerator over denominator. It actually creates a cute little fraction. It's blank on the top, blank on the bottom. Fill in what we have here. That's 6 open, 118.1 close. Subtract open, 37 close, open, 17.4 close. Go down. This keeps you from having to keep the numerator and the denominator separate. You would have to have 2 whole different sets of parentheses if you didn't create this N over D button, okay? So that doesn't make sense. Y'all can tell me later. 6 open, 289 close. Subtract from that, open, 37 close, the x squared button, which will place that 2 in the exponential field, like touching that 37. So it's going to square the 37 before it subtracts it. And then you hit enter. Okay? So this right here, this is the M. This is the slope of this regression line. And I'm going to round it. So I'm going to do the tildes, basically. The M is approximately equal to. I don't really know why I rounded it to this. I guess it told me round 4 places for my M. I think it does. It straight up tells you round 4 places for your slope, and I think 3 for your y-intercept. So read, because if not, even 1 decimal place off will tell you you're wrong. Everyone get 0.1775. Okay, that's the slope of this regression line. We need to solve for B. And then if we're asked, a student tells you that they study, 3 hours, because I don't have that on there, 3 hours per week, we could use this equation to predict what their actual GPA could be. Does that make sense? Okay, so let's actually do our B now. Our B is equal to what? The mean of our y values, subtract from that the slope times the mean of our x values. They broke that down a little simpler for us. I didn't write it here. It is going to be the sum of your y values divided by n, subtract m times the sum of your x values divided by n. So I'm going to kind of work here. Okay, B equals the sum of my y values. I have that, don't I? It's 17.4. Divided by what's n? And then subtract from that our m, which is 0.1775. It's being multiplied to this. I kind of wish that in the formula they did show you here that it's useful to know that, like, when you plug this stuff in, you should use parentheses. If you did the multiplicative symbol, it looks like an X on your calculator, that's fine, but I would recommend do your parentheses. The sum of our X values is 37 divided by 6. Oh man, I opened with blue and closed with black. Whatever. Okay, so if I do this, I'm going to do math left, enter, enter. Just kidding. Why'd I hit enter twice? Don't hit enter twice, y'all. Math left, enter. There we go. There's my little fraction button. Okay, and I noticed that I have 17.4 over 6. I now need to scoot over to the right. That gets out of the denominator. Let that focus. And then I'm going to subtract 1.775. And I open my parentheses, and I need another little fraction right there. So math left, enter. 37 down 6, enter. Did y'all get the same thing I got?
Mm-hmm.
I've got a scribble on here. Oh, okay, sorry. On my paper, I actually did 17.4 divided by 6. I got 2.9. Like, I did it step by step by step. So that's what confused me, because I was like, why do I have the correct thing here, but I don't have it right here? B is 1.8054. Okay. So now what I can do, right, our line, our Y hat, the regression line that is best fit for all of these different data points from these students is mx plus b, right? M is our 0.1775 x. That's a variable. We don't know what that is. We can, if given a x value, right, a time spent studying, figure out what the predicted value would be for their GPA, but here it's going to be x. So mx and then plus b. Y'all, if your b ends up being negative, you would use the negative. I think each time I've ever seen it, it's been positive. 1.804. I'm out of page. I'm going to switch, and we're going to actually calculate what someone's GPA could possibly be. Oh, okay, no, that's good. That's what this next one is. I didn't know for sure if I actually did that, but we're going to do it. Okay. Because the regression line is y hat equals mx plus b. Our m is the 0.1775. Our x is a variable. So if we're given other time studying, we could plug it into here and figure out what their predicted GPA would be. But it's literally a variable. So, and then our b is that value right there.
So is that our final answer?
Yes. This is our actual regression line. It's like I ran out of room. Our line of best fit, or our regression line, is this right here. I kept kind of pausing when I was looking at my page because I did my B kind of step by step, and I ended up with, wow, tenths, hundredths, thousandths, maybe 10,000ths. My 10,000th place was different by one number, and I kept staring, and I'm like, I don't know if it was because I worked it, and obviously this isn't a homework example, so I didn't put it in in the computer, and it told me no. But just know that, like, that would probably be if it's like, no, you know, you're close to the answer, but you're not completely right. I would work this maybe like kind of step by step, not really rounding anything, so that you get a more accurate answer. Goodness gracious. I feel like it does it more often now. Okay, y'all, we actually are going to have like a whole page of sketching a regression line. And it's going to say, like, if, you know, given a student studies for X amount of hours. Right? That's why I use X amount of hours, because that's our X value. And then what we'll do is we actually graph it. And then I have one example from the homework, like as close to the homework as possible, and all the steps you need to solve it. Okay, so when we come back from our little break, that's when we're going to do that. Okay.